All right, so let's talk about networking. Nmap is, of course, the main tool you use all the time to connect to servers and find out what's up. So if you can turn off the firewall and enable remote desktop on a Windows machine, that's going to start listing on 3389. And so you can detect it with Nmap. So if you just do Nmap and the IP address, it will automatically scan the most common 1000 ports, and it will just give you minimal information about them, whether they're open or shut, and just the name of the service based on the port number. And there's a lot of advanced options. A will detect the OS version. V will find the version numbers from the banners, and you can use this to scan all 65,000 ports, this to scan much more rapidly. And this is how you grab banners with a banner script. There's a lot of cute tricks. So everybody has to learn how to use Nmap, and it's very, very popular. The only thing that's annoying is it takes like 10 minutes to scan all the ports unless you do this, and then it's only 2 minutes, which makes it a lot nicer.
Mass scan. I use mass scan a lot too sometimes. We just want to do a simple TCP without the actual ACK.
Yeah, but mass scan mostly does just one port on many machines. That's what it's designed for, right? To scan the whole internet.
You're right. You're right.
So that's what he designed it for. So yeah, find dot and find slash. Find dot will find files from the current directory. Find slash will find files from the root directory. That's the difference in a question in chat. Anyway, so there's some services to find on my server here. And the first one you can get with just the default 1000 ports. And the next one, you really have to scan all 65,000 ports to find it because I put it on a goofy port. Anyway, so that's Nmap, which is very simple. And the next one is Wireshark, which I was real pleased. There was a CTF a few weeks ago where they had a good Wireshark challenge. So I put that in here. So Wireshark is another tool everybody should know how to use. It totally teaches you the TCP IP model. If you open up Wireshark and connect to a server, you'll see how it works. I connect to 443 HTTPS. I send a SYN. The server replies with a SYN ACK. Then I send an ACK. That's the TCP handshake. Now I'm ready to send data both ways, and it won't get mixed up with anybody else's data. It's not encrypted yet, but at least will be labeled so I can communicate with the server. And so if you're using plain text protocols like FTP and Telnet, then your passwords are just sitting there, just right there to read. And you can just read them right off the wire, and Wireshark will make it easy. HTTP is the same thing. You have a login form, and you'll see the password just down here in the form items. Following a TCP stream is extremely helpful. This is the way I used to use Wireshark, looking at packets one at a time. This is for the birds. You're hunting through weeds. What's cool is to look at a whole stream. You right-click and follow a TCP stream, and then you get a beautiful printout like this. I went to like a talk, and they had these things. I said, man, I got to use those. Everything I send up is in red. Everything the server says back is in blue. All the addresses are removed. If all the packets are combined into one stream, this is really the boss way to do it. The only thing that's annoying about it is most servers are configured to do this content encoding. So they zip the stuff before they send it to you, so you can't just see it right here in plain text typically. You have to unzip it, which is a little annoying, but Wireshark will totally extract it for you. You can extract objects that are moved by HTTP or other common protocols. One other thing to know about Wireshark, by the way, is that it is very insecure. Wireshark is like Firefox. You know, there's Firefox, and then there's all these extensions. And the extensions are written by just random people, and they're not audited by anybody. So adding those extensions gives you a lot of vulnerabilities. And Wireshark has built-in protocol handlers for common things like FTP and HTTP, but there's a whole community that keeps writing more protocol dissectors that they just put in Wireshark, and a lot of them have vulnerabilities. So if you turn on Wireshark sniffing on live network traffic, it is pretty easy to take over your box through Wireshark. You are not supposed to use it that way. You're supposed to use TCP dump to collect the traffic and use Wireshark to analyze the PCAP files later. That is the secure way to do it. And that's what
Can you not just add yourself to the Wireshark group to run it as root?
You can do that, and then you can still get command injection on you, but it'll only be as a lower privilege. But it's not a good idea. Another thing about Wireshark is it will just fill up all your RAM and crash. You know, it's not intended to really monitor live networks. You do it a little bit in like a training class, but if you want to monitor a live network, you use TCP dump.
Okay.
command line tool. It's much safer. Wireshark is really to analyze a capture, and then you have all these beautiful analysis tools to go into detail. That's what it's for.
Same thing like T-Shark.
Yeah, T-Shark is just the command line version of Wireshark, and as far as I know, it has the same vulnerabilities, but I'm not quite sure.
Okay.
I don't think it's, yeah. Anyway, so there's various things to go here, and there's a whole series of things you can find. There was this nice PCAP that came from CTF about a few weeks ago that was very nice. It's from Red Team CTF in May, and this has a bunch of advanced resistant threat attacker traffic. So it's got encrypted communications, and you can find the port number of it. It's got a tool used to encrypt the packets, and you can find that tool. You can find the hash of it because they downloaded the tool in the PCAP. There's a TLS communication, and you can find the private key, and you can decrypt the TLS traffic in here, which is pretty nice. And there's port knocking. Port knocking is where you do 3 connections in a row, like 1,000, 2,000, 3,000, and they're all closed. But if you knock the right way, it then opens another port for a couple of seconds. This is an old trick to have a secret backdoor. So you're not listening on a port all the time. You're just waiting for the knock, and then you'll listen for just a second or two. So you can run like Nmap, you'll never find it. Nobody will find it unless you know the secret knock, you can't get in. There's a more modern version of it called single packet authentication that sends an encrypted packet, which is considered cooler, but the old-fashioned one was port knocking, and in this malware traffic, they had port knocking. You can find a series of connections, and right. And anyway, so there's a lot of fun things to hunt for there in Wireshark, which is good practice. And the last one is Scapy. You know, I found a vulnerability years ago. I wasn't the first one to find it, but there was an IPv6 vulnerability that would blue screen of death Windows machines. And I found it and I said, oh my God, this is dangerous. I better not tell anybody. I'll talk to Microsoft. And I knew some friends that were inside Microsoft, and they put me in contact with their team. And it only took like 3 days for them to say, yes, we know about it. We don't care. We're not going to fix it. I said, okay, then it's homework. I did it at DEF CON, I did everywhere, and I finally killed their latest version on stage at DEF CON. Then Microsoft fixed it because they were humiliated. But anyway, but for like 3 years, you could trash Windows machines all the time with this thing. Anyway, and when I contacted them, the other thing the Microsoft security team told me is you should use Scapy. Scapy rocks. And
I've heard of Scapy, but I don't know nothing about it, so I'm
interested to hear this. They told me to do it, so I tried it. Scapy does total rock. All you have to do, it looks like I'm missing some carriage returns here in these commands, but you can just install Scapy, and then in Scapy, you can just create packets. You can create an IP packet, and it will just create it and fill in source and destination, loop back address, and everything. It fills in all the headers. You can tell it destination, google.com. It'll just turn it in here. Then you can do ICMP in IC. So now you make an ICMP packet, and then you can send and receive one IP and IC. This will send a ping. It will send a ping to google.com, and you'll get the echo reply coming back. You can totally build packets layer by layer and send them right here. And you can make a line of Scapy with a loop in it, and you can make your own Nmap in Scapy with just one line of code.
So are you speaking of just denial of service attacks on this, or
you can do anything? You commonly use it to test firewalls and everything. You can craft any kind of packet you want. You can make malicious packets. You can even specify them bit by bit. You can take a Wireshark trace and make a packet just like it. You know, you can totally make any network traffic very easily.
Okay.
So totally
I saw ICMP. I just didn't know if you could do any other type of packet.
Oh yeah, I've done a bunch of them. You can do anything you can think of. You can very easily make it in Scapy. So then I've got some pings here. You have to send a ping containing your name, ping containing a certain data. You send a ping, and when you send a ping, my server will put up a page for just a few seconds, which has the flag in it. So that's one thing. And then you can send UDP with Scapy. So if you send a UDP packet with like flag me in the data, it will give you a flag over UDP. And so on. So you can just practice making a couple of custom packets, but Scapy is awesome and it's incredibly easy to use. It's all based on Python. You can, anyway, all right. So that's the networking section. And I'm just gonna stop recording and